Hi, my name is Pavan Sangha and this is my project for inclusive gaming. So, as we know, technology is rapidly advancing, yet certain aspects such as accessibility for players with colorblind deficiencies are often overlooked in game design. So what this project will implement is a colorblind filtering system aimed at enhancing the gaming experience for visually impaired players. This prototype filter simulates how players with colorblind deficiency perceive both the user interface and in-game environments, allowing the developers to better understand the visual challenges they may have. So I will be focusing on 4 types of color blindness. One being deuteranopia, which is green blindness, achromatopsia, which is total color blindness, protanopia is red blindness, and tritanopia is blue and yellow blindness. Originally, I wanted to use Unreal Engine 5 for this project. However, Unreal Engine already has a built-in colorblind system, so if I was to show you, so here in the editor preference, you can see that it has an accessibility bar. Here you can change what filter you want to use. So what I did was implement that in-game. So if I was to play this now, I can press this button and it changes the filter for the in-game. It also changes the sky as well. However, this wasn't innovative enough for me, as I'm just using the game's engine rather than creating my own colorblind filter. So what I decided to do is scrap using Unreal Engine 5 and use Unity, as they didn't have a built-in colorblind system. So now this is the final project that was created on Unity. So what I had to do next is create a colorblind filter using script, but I need to find the values for each of the colorblind filters. So I've done this by using the values provided by Alan Sacconi from this website here. So because of the help of Alan, I was able to implement this into script. So here you go, these are the values I got from Alan. So now that I've created a colorblind filter, I implemented it into the game's menu. So if I was to run it for you now, okay, so here you go. So this is the environment. As you can see, it's quite colorful as well. Alright, and this is the place where I'm going to show you the filter in progress. So this is the menu, and if I was to go on to the settings, you can see there's all 4 options, and also normal as well. But if I was to click on protanopia, it's red blindness. Go back to the in-game. As you can see, it's changed the environment color as well, and it's the same with the others as well. So if I was to go to deuteranopia, it's the same as well. Tritanopia, it's like this. Yeah. And final one, here you go. See, it's completely colorless. So this project, in my opinion, can be quite important for the gaming industry, where accessibility is evolving and becoming greatly important in consideration. By integrating a colorblind filter, game developers will be able to ensure millions of players with colorblind deficiencies enjoy an inclusive and engaging experience. So how can this project be improved further? So I was thinking maybe creating a correction option, adjusting the colors automatically for the player and what's best for them. This can potentially reduce workload for developers instead of hard coding the changes. So overall, if the gaming industry continues to prioritize accessibility, solutions like this colorblind filter will contribute to producing a balanced and enjoyable gaming experience for all players. So the next project is about games technology for public spaces and how games technology can be used to create playful experiences for public spaces. The use of modern technology for playful experiences in public spaces has gained increasingly popular in recent years, especially for mobile games. They have become more powerful and socially normal to carry around. Many games are designed for individual play, but this project is set out to explore how mobile games can be designed to encourage co-located, meaning face-to-face, shared experiences between two players on a single device. So the initial concept for this project was a mobile-based version of Connect 4 using Unity. I've made progress on this prototype, but it was ultimately discarded. The game lacked originality and did not meet the expectations in terms of engagement or innovation. As a result, the project pivoted entirely towards a new concept, a split-screen endless runner. This new direction offered a more unique and socially engaging experience, which is more aligned with the goals of this project. This two-player split-screen endless runner was inspired by games like Temple Run and Subway Surfers. This game allows two players to race simultaneously on one screen by avoiding obstacles. The choice of a split-screen format was important for this design as it allows both players to physically be present with each other. This encourages face-to-face interaction and playful teamwork. So this game was created on Unreal Engine 5 instead of Unity this time. So this is what it looks like. So if I was to run the game, it generates the road. So here you go. So how it creates more tiles. So if I was to be in game, like here, I can press enter to get two players in and they can run around. The aim and objective, like I said, is to avoid obstacles. So if I was to hit that, the character dies, but it also, the other player can continue on as well. See? And both players will be sharing points, as you can see on the top. So they'll be working together to build as much points as possible. You know? It definitely needs more obstacles in my opinion, just to make it more challenging. Maybe some more abilities, speed abilities, coins, things like that. So I'm just gonna So I'm now in the blueprints, and this is what it looks like for one track. So here's the obstacles on the one track, and if I was to compile, it changes the position of each obstacle, making it unique every time each track is developed. There you go. So this is recording on my phone using this mobile game. So if I was to play it, it generates the game here, and you can see if I press tab with two fingers, two players join, and they can play on one device with two analog sticks, and you can run together. But you can also exit the game by tapping with three fingers. There you go, perfect. So yeah, that was the final result of the project, and I wasn't able to create an app for this game on Google Play only because it costs £25. So overall, the project demonstrates the potential for mobile games to create socially engaging experiences that extend beyond traditional networked multiplayer systems by focusing on a co-located play interaction. The prototype also offers a playful, spontaneous alternative to the often isolated nature of mobile gaming, especially in public environments where quick, shared fun is most impactful.